Yeah, Dev.
Yes, the screen is visible.
So, in the last session, we have already covered till the modern techniques we are using in NLP, including the attention mechanism and sequence to sequence modeling. Now we will see an implementation of such techniques in real life, in real world applications. So for that case, we have taken a data set which includes 1.6 tweets, where we will be feeding these tweets into a model, which is basically logistic regression. We have started simple. And after we train this model, the model will be able to categorize negative and positive tweets. It will be able to capture the sentiment from the tweet. If you talk about the pipeline, it will be we feed in the tweets. It does tokenization where we split the sentence into small tokens. Then we apply TF-IDF where we look for the frequency of word with reference to the frequency of document. Where the frequency of term is inversely proportional to the frequency of document. The fact to be understood. The word which is more frequent across many documents is considered to be less important, will carry less of a value rather than a word which is appearing fewer times across multiple documents. That's the whole purpose of using TF-IDF to identify the uniqueness of words in a corpus. Then we can implement embeddings to make it um, more competent to capture mm, mm, context of a sentence in a way where TF-IDF fails sometimes. Then we create the model in pickle form. We use text to give sentiments. So let's just directly jump into the code as we have already discussed the theoretical part in the last session. We were just missing the code. This was screen visible.
Yes, it is.
So in the last class, we have already seen how we input text out here, uh, and we get the sentiment out of it. Before we jump into this demonstration of analysis, let's understand the code, what you have actually done. So if you recall the presentation, if you recall the slides, you can remember the very first part we do in any NLP task is we bring in the required tools and libraries. So here we have imported a NumPy for basic mathematical calculations and all pandas to plot the graph. Then we have NLTK, which involves the basic actions like removing stopwords, executing stemming. Stemming involves cutting down the word into its original root form. So such kind of basic implementations are there in NLTK. And from sklearn, we are importing the TF-IDF vectorizer, the train test split, logistic regression, and the metrics, the accuracy score. Since we are using a balanced data set, which is equally divided in positive and negative sentiments, we are just sticking to accuracy itself. We're not going into other metrics. So in the other step, in the other block, you can see we are importing energy cap where we already download the stopwords. These stopwords are fed into them. We just need to download it for our use. As you can see, the stopwords, there are a set of examples in the stopwords. You can go through it. These kind of words barely add any meaning, any context to the text for cell-level analysis. That's why we remove it to lower the computation. So after we feed in the stop words, we provide the CSV, the training CSV we have, which includes the 1.6 million tweets. If there is an encoding issue, we fix the encoding. As the encoding was in UTF, we fix it to ISO as per our convenience. Then if we look into the data set we have uploaded, we can see multiple features, multiple attributes out here where we are not able to. It's not that of explainable. The attributes are not well named, as this might be this might be the serial number of the this might be the user ID, but it is not making it that clear that it's a user ID or this is the timestamp. We don't have a proper naming for that. So we will just change the name of the attributes for more clarity. That's what we are doing here. We change the column names with target, ID, date, flag, user, and what text they have given. So after that, here 0 represents the positive ones and 1 represents the negative one. My bad, sorry. The 0 represents the negative and the 1 represents the positive one. My bad. So the target is what we are predicting here. This is what we are feeding into the model. With respect to the text, we are making it learn the pattern in the text, and we are making it understand that if such kind of sentence comes, then it's a negative statement. We are somehow making the model learn this pattern in the text to the data we have. So this is the overall head of the data set where we can see our ID is there. Then we have the date and time. Then the flag raised by the user, name of the user, and what text the user has posted over the social, which is actually Twitter in this use case. Am I clear till now? Is there anything
Mm.
confusing?
No, no.
No.
Okay. Then, a good ML engineer, as a good NLP practitioner, you should always look into some of the basic aspects of a data set. That includes the shape. What is the shape? As we could see here, we have these many columns. It's around 1.6 million, and we have 6 columns dividing these rows into 6 different attributes. Uh, After that, we have to check for the missing values, whether our data set has any missing value or not in any of the columns. As we have checked for it, we don't have such missing values. Even if we have missing values, we have multiple methods. We have already discussed it. If it's a numeric, we can take a mean median mode of it. Or if it's a categorical value, then we can go for sampling, where we had understood normal sampling, where we simply replicate, make a duplicate of the present information, the information which you already have. Then we have synthetic sampling, where we create synthetic what do I call it? Synthetic values, synthetic categorical values for the missing ones. As we don't have something like that in our use case right now, so we will not go into that much. Since we have seen there is no missing value, we can conclude that our data set is perfectly balanced. Then we are supposed to divide the data set into 2 parts, for one for training, other for testing. Okay. So as we can see, now we have around 800K of positive tweets and almost near to 800K of negative tweets. We have perfectly divided the data set into two halves. Now we will apply stemming over it so that we reduce the words into their root form to capture more of information out of them. If running is there, it will become run. If eating is there, it will become eat. Such kind of stemming is applied over them. In stemming also, you can see in the third line of this code, we have converted all of the text into lowercase. As we have already covered that we should feed in lowercase text only where we only use uppercase where it's most relevant, like in the names of countries like US. If you convert it into smaller US, it will completely lose its context. So we have to be sure that we don't overdo it so that we lose the essence out of the text. So we are applying stemming all over the text in the data set. We just mentioned the parameters in the last code and then we are applying stemming. After stemming, we have got the data set almost cleaned and ready to be fed into the model. So the last split we have done was particularly focusing on the positive and negative tweets. Now we have to split the data set in a way we can feed into the model for training and testing purposes. For that, we have taken X train and X test and Y train and Y test. We have split the data. We have not taken any random state here. After we split the data for the X train X test and Y train Y test, we are assigned to convert the textual data into vector form, as we have understood that machines won't be able to understand the textual data. The very first task in NLP, after cleaning and all the basic pre-processing tasks, what we do is converting text into vector form so that it is more useful for us, is able to capture more of information from the text, for which we have used very basic and beginner level of vectorizer, which is TF-IDF, which we know is used to seek the uniqueness of a word across a text. It marks the uniqueness of a word in a corpus. Accordingly, we have applied vectorizer over our splitted data set, which is X train and X test. Can you see the result has printed?
Mm. Yes, yes.
So it has one by one went across the tweet and it converted it into the vector form. The vector form which could be fed into the machine. So it's a very long series of value, as we are using a very big data set. The moment we convert the text into vector form, the task we are left with is to train the model. For training the model, we have taken the very simple algorithm, which is logistic regression, well known for classifying categorical values. So here the category is positive and negative, and we feed the model with the data we have. If you feed the model with X train and Y train, you get a logistic regression model, which is now trained over the data we have provided. It is now able to predict outcomes. It is now able to predict sentiment over new text we are feeding in. So as you could see, this is not something very much of rocket science. If you go into basic NLP, it's very simple, as we have to consider the fact that this is just a beginning point for any NLP task. You just can't rely on logistic regression for your answers, for your classification. Obviously, it is a good start, but if you are going into more complex NLP tasks, you have to consider more complicated architectures or algorithms like naive bias or BERT, which is actually a transformer model. But for now, we are only sticking to logistic regression, which will come under supervised learning and machine learning, where we teach the model um, by giving in the uh, both the aspects. We provide what do you call it? Label data, where we label the data. We tell the machine that this is the positive part, this is the negative part, and the machine tries to mimic the pattern in the data, and it later performs classification. It later tries to predict sentiment over unseen data. That's the whole purpose. If the machine is able to predict sentiment over unseen data, then somehow our model is accurate. And in metrics, if we want to understand what metrics we have achieved in our model training, so here we have achieved 0.77 as the accuracy. So this is our average accuracy. This isn't too good and it isn't too bad also. Why we haven't achieved a very good of accuracy? Because we haven't performed multiple pre-processing tasks we had. We we can increase this accuracy by considering more of pre-processing tasks, by filtering more of the text. For now, we have achieved 0.77, which still has a scope for improvement. So somewhere I rely on you people to seek for methods to look into this code and seek multiple methods to increase this accuracy. So from my end, this will be the assignment for you people. After that, we are now all ready to predict the sentiments. Why? Because we have trained our model for it. We can ask the model now to predict the text with negative or positive. That's what we are doing in this code block. So this is in this code block we are creating a function which is now be able to predict the sentiment. The function name is predict sentiment over the text we have given in. So for testing, we have just simply given two of the statements, which is very obvious with their sentiment. And the machine, the model is also very much able to predict the right sentiment out of it. If you can see in this code block where we are testing our model. Then we are saving our pickle file, which pickle file is what the format is, the format in which we get the model. That's what we have used in this code. There are multiple formats to save the model, but mostly we use pickle. So we have saved the model into our local database. So are we clear till now? Like this is just a walkthrough in the code, what we have done in each step. Are we clear with the steps, what we are doing? The thing which I have asked you to increase the accuracy, will you people be able to do it?
Yes.
You people will be only able to do the increase in the accuracy if you go through the code thoroughly. If you understand the code, then only new ideas will click into your mind. So if you find any part of the code difficult, any block of the code difficult, I can go through it again. I can explain it again. We are done with the code, we can move into the demonstration where we have used Streamlit to run our web app, where we can classify the text in real time. So I want you to volunteer and give me a random text. Lakshya, this one, any one of you. We have to fit into a text and we have to seek sentiment out of it. Any text from your end.
Okay, so it should be like any sentence or any
Any
word.
sentence, any sentence which you might post over social media, your thoughts, anything.
Okay, so we can write a. I'm very excited to join a new job.
So as our model is able to predict that it's a positive statement, I'll
Right.
seek for a variation of the text from Lakshya, a negative aspect of it. So check whether the model is able to predict the negative text.
Okay.
So Lakshya,
Yeah, for a negative statement. Give me 1 second, let me think. Hmm. Oh, negative. Uh, But it could be anything.
I'm really sorry. I was just getting a call. Sorry. Can you please repeat if you have said something, Lakshya?
I was just asking, like, it could be anything, right?
Anything, any random thought in your mind.
Um, okay, let me just think 1 second. I could say, like, I did not probably clarify. Sorry, I did not, get selected for the next round of an interview. Does that work?
It's stating this also as positive. Shouldn't be
But it should be
this.
negative.
Yeah,
Yeah,
should
it
be.
should be negative. Yeah.
So since we have to consider the fact that our model isn't that accurate yet.
Yeah. Instead of say they say I was rejected in the interview. Uh, Not is a stop word, so it will actually be eliminated from the text.
Mm, right.
See that.
Oh,
Why is it stating this?
really?
We are facing some biases that it is claiming some of the statements as positive. Maybe that's because of the low accuracy we have. We have to filter out the text more thoroughly. We are losing some of the essence out of the text. Maybe what Sir said is right, that we are considering not as a stop word out here.
So here, not could basically be a positive or a negative statement.
Okay, I got the problem. Like we are using didn't as a stop word. If you can see in the list of stop words, there is didn't in the stop word. That's why it was happening. It just removed didn't from the. Can you see that in the list of stop words? Have did.
Yeah,
Yes,
there's not
yes.
So
as
that
well.
is the problem.
Yeah.
Not
So
will work.
specifically when it comes to, and this will be your job as a data analyst, as a data scientist, Rizwan, Lakshya, that sometimes when we are specifically when it comes to reviews, right? Say it is about a movie review or maybe a product review. So let's say Amazon, right? Or maybe Flipkart. If you say that the product is not good, right? And because you have got stop words in play, so you obviously will, I mean, the system will behave that it will take out the not from it because it's a stop word. But as analyst, you have to take that call that you want to retain certain words because otherwise the meaning will be lost. So what they've just did is a representation of it. Yeah, back to you, Dave.
Yes, sir. So we have to be very careful while we feed in the stopwords. We should not. This is the default stopwords we get in the English corpus along with the NLTK library. So we have to edit it according to our use. We simply can't remove everything as we see. I've seen the problem with that. That if you feed in everything available in the stopword as the for the removal purpose, then we might actually lose the essence out of the text. We might not able to capture the sentiment. As we did the mistake, we didn't notice that we were supposed to involve not also in the statement because most of the reviews carry such kind of words. Most of the tweaks carry such kind of word. So in sentiment analysis specifically, I suggest that you should not add did not or didn't in the stop words. Or if it's there, then we can do lemmatization or stemming to convert it into its root form. If didn't is there, we have to normalize it to did not. So we have missed one step before we have like we have included stop words. We should have normalized the text. If you remember, the very step in the pre-processing is normalization. Do I need to go back to the presentation to just give you a recap? Uh,
No, I guess we can continue like that.
so okay. So here we were supposed to do normalization. Before we remove the stop words, normalization is important. And then only after normalization, problems like did not will get solved because did not itself will become didn't itself will become did not. It will be expanded to its root form. So one suggestion out here is you can note it down that before we remove stop words, we should imply normalization. Apart from that, anything is wrong in the stop word. So for now, with the accuracy we are able to we are able to capture sentiment from a very obvious statement, very obvious keywords. Like here, the word hate is very obvious that it's a negative statement. So if you use words like I didn't like this, I haven't went that place. So such kind of statements are not pretty explanatory in themselves. Even the vectorization won't be able to capture for such statement. That's why we have moved into the latest and the newest of NLP techniques like BERT, PALM. Such kind of transformers are context aware. They carry context with them. They just not read the word with their meaning. They are not just looking for the uniqueness in the word like TF-IDF is doing. They are carrying context beyond frequency or beyond sparse vector value. They are able to create very dense vector values which are about 300 or more than 300 dimensions, and they are able to capture a very long term context about a text. If it's about the grammar or if it's about the preceding or succeeding words, it's able to capture a long range context with that text we are putting in. So this is just for a demonstration. We can't expect much from logistic regression. It's good for basic tasks. It's good for simple tasks, simple classification tasks, but we can't rely on it for complex sentiment analysis tasks. Because in real world data, we can't expect the user to use such kind of obvious keywords like hate or love. They might come up with words like didn't, I haven't, I shouldn't have done that, they shouldn't have done this. So such kind of statements should be dealt with more more care should be not brushed under the carpet by these stopwords. So that's what I'd like to conclude over this. And apart from the manual text input, we have another option for it also, where we can directly extract tweets from the user. So for this, this is also another task for you people to include a library named TP. I'll type it out here. This TP, and I want you both to understand about TP and how we can use TP to fetch real-time tweets from users. So these are the two things we will be discussing our next. So will there be a next class with the rest of the team?
I think we wanted to close this round on NLP. I think the number of sessions that we had planned, we are already done with that. So just in case if there is any kind of doubt, I think we can definitely get into that conversation with them.
We can get into a quick conversation where we can see our progress, whether these people have completed their assignment.
Absolutely, absolutely. Yeah,
Both
yeah.
of these assignment that whether they were able to get more of accuracy and a bit about VP also. If you will fail to fetch real-time tweets, then obviously I'm there for that to guide you up. Um, uh, are you clear with this thing? What you're assigned with, Lakshya and Arizona?
So
Yes.
from Tweepy is like it is included in Python only. So it
Yeah, it's a
analyzes
library.
the yeah,
It's a
it's a
library
Python
to
library.
fetch real-time tweets based on the user.
Okay, so will it only fetch the tweets or like it would also fetch the user data also like the followers or the like
Not
how
really.
many people
Not
have
really. We
liked
don't.
like
We don't. We don't need that for the tweets. Not really. It will not be required for our use.
okay.
Here, we only need the tweets from the user. So if you after you bring in the real-time tweet analysis, you just need to add the name of the Twitter file. It will fetch all the latest and it will stretch back to all the tweets available on the platform.
Okay, okay.
So we have simply used a Streamlit web application to use this. You can see we have downloaded the stopwords. We have loaded the stopwords from NLTK, then we have loaded the model, and then we have vectorized it. So for vectorization, also as for the vectorizer, we also have a pickle file which carries all the vector values for us, all the TF-IDF values. So whenever you do vectorization, it is preferred that you carry a pickle file which has all the vector values, which has all the embeddings. To be more specific, these vector values are called embeddings. These embeddings are very important to understand the relevance of text. Um, if it's a simple embedding, if it's a frequency based embedding, like frequency, there are three types of embedding. First of all, this point has to be remembered. Embeddings are divided into three different parts. First is frequency based embedding, where we have a bag of words and TF-IDF, which are simply known for having a count, either count of the word or count of the unique words in a word. Then we have word embeddings. Word embeddings are where we involve word to vec, globe, fast text. These were the word embedding techniques we had. And then we have context embedding, where we include transformer models. So wherever the word context embedding comes, or wherever the word context comes, should click in your mind that we are talking about the transformers. Because only transformers are able to capture context behind a text. Apart from transformer, if you are seeking for something simpler, you can go with sequence to sequence model, where we use smaller architectures like LSTM or GRUs at encoder and decoder level. We use a set of GRUs at encoder to take in the text which we are giving in and convert it into vector value. and at decoder, the response by the machine, the response by the model is decoded back into textual form, because obviously the response created by the machine is also in a vector form. The machine also gives out vector data. So that vector data has to be converted back into textual form before it is presented to us. So if you remember, we have created a sentiment prediction function in the last code. We are using it out here. Where we are executing pre-processing to lower the text, to split the text, to match the words for the stop words, and to transform the text into vector form using the vectorizer. Then we are using the model to come with the value of negative or positive. So here you can see, if you remember in the last class, I have also told that without using Tweepy, I was trying to fetch real-time, what do you call it, tweets from Twitter. But I was using very outdated method, which is knitter. It actually has multiple mirrors which has API, which has the functionality to API called Twitter, and able to fetch tweets in real time. For that, I have given multiple instances also of knitter, but it was failing because the newer versions of Twitter don't support knitter. They are based on TP or they're not able to these scrappers are not able to fetch tweets out of the Twitter now. This is an outdated method. That's it. Then we just have the UI of the app. Yeah, yes. Yeah, just given the code for the. So we have understood the code for the model creation. Then we have checked the code behind the app we are seeing out here in stream. Anything you people find difficult in both of them, we can click through it. Daksha is any doubts. People didn't find that stable.
I sort of still have the confusion. Like when we put the not word, like you showed, like in the list of words, there was didn't as well. And then
Yeah.
two, like three, four lines below, there's not as well. Both of them are included. So like why did it like show positive for not? And then when we put didn't, it showed negative.
So it was showing positive for didn't and did not both because we removed it as a stopword from the text. We were not
Okay.
supposed to remove it. We were supposed to do normalization over it so that before the stopword thing comes, it is already converted to did not, and the word did not should not be there in the corpus of stopwords. As default, it's there, but for our use case, which is about sentiment analysis, we have to remove it. We have to remove the word did not from the list of stopwords we have. Because for sentiment analysis, such kind of words carry a lot of importance. But if you talk about use case like text extraction uh, or yeah, text extraction, where sentiment is not a matter, where we are just seeking keywords, key insights from the text in such kind of, for example, if you talk about blocks. So in blocks, did not or such kind of didn't don't carry such importance. In blogs, we look for keywords. We look for a context behind the text, textual data we have. We need to understand the summary behind. If you are doing summarization, so in summarization also didn't won't carry that much effect. Because we are not seeking sentiment out here. We are not bothered what's the sentiment. We are bothered what's the key value to be understood from the whole text. Just imagine if this 1.6 million was a number, it was a count for a word in a book. This was a complete book in itself. So if you need to summarize this book, then you don't seek a sentiment behind the book. There might be statements where the author must be positive or negative, but we don't need that for summarization. We just need the summary, we just need the key insights from the book. So in that case, these stopwords are of perfect use. We just don't need to edit it. But if you're doing sentiment analysis, this is a very um, sensitive use case, because first of all, it's based on real world data which people are giving out through social media posts or reviews. They here even uppercase carries a lot of value. Like if something is written in uppercase, it shows aggression, or it shows a strong emotion. Have you seen those reviews with very like it has uppercase headlines, uh, uh, waste product or like awesome product? So they the users sometimes post that review with a uppercase heading. So that uppercase even carries some meaning in sentiment analysis. Sentiment analysis is a very sensitive, very you have to be very considerable. You have to be very mm, um, you have to consider a lot of fact when you're doing sentiment analysis, because this is about the emotion of the word, emotion of the user, just by analyzing the text. If it's a human, we can look into the tone, we can see the body language of the speaker. But here that machine is not able to capture such things. It's only looking at the text and trying to making it make out trying to understand what the user is trying to convey. So for such use cases, we have to be very careful with the choice of stop words we are making.
Okay, got it. Okay.
That's why no one does sentiment analysis over logistic regression. I just did for uh, educational purposes to make our code simple, easy to understand.
And also to add to that, that probably was one of the reasons why sentiment analysis, it has taken some time to mature. It's been there almost for the last 15 years, but it actually has shown improvement very gradual. So maybe in the last 5 years or so, and specifically ever since transformers came into being, the sentiments are now being measured in a much better manner. Otherwise, some of these challenges, and when it comes to context, when it comes to intent, uh, these sentences, these combination of sentence words actually can throw any algorithms uh, here and there. So you will, when you, as a data scientist, Lakshya, uh, this is where your uh, applied understanding will count. That how when such kind of issues you face, right? You have to go and investigate what is going wrong, right? That like the way we picked up dent, maybe that was not sufficient, right? We need to do something more to it. But this is where we have to build our muscle, uh, Lakshya.
As you can see, after we have removed the stoppers, we haven't mentioned can't some anywhere in the list of stoppers. So that's why in the resulting data set we have still have can't. Is upset that he can't update his Facebook whatsoever it is. So now if we will give a statement with a can't word in it, it might tag it as a negative statement. It's all about the stopwords you're feeding in. It's all about the pre-processing you're executing of the text. Uh, Who is a better data scientist? Everyone can write this code. Everyone can do all these tasks. But a better data scientist is someone who can think so thoroughly that he or she is able to understand the data set at first place, understand the different attributes involved in the data set, and then understand the use case given to us. What are we supposed to predict? What's our target? Based on that, if you pre-process the text, you will get a better of a text, which will result into better of a model, and which will eventually result into a better metrics. So this is the whole process. If someone who is a better data scientist will just look into a data in a way others can't. The whole job out here is to understand the data set, to understand the use case. Accordingly, you design your, accordingly, you clean your data for the model. You don't have to overdo it. You know, you just can't do less of something. You have to be optimal. You have to be optimal enough so that that essence is not missed out from the text, nor we are putting into gibberish into our model, as we have understood the principle that garbage in, garbage out. So we can't afford to put in garbage. Also, we can't afford to lose a main essence out of the text. We have to look for a balance. We have to find a middle point where things get balanced. Where we like, are you able to understand what I'm trying to say? So actually, a data scientist is someone who creates a balance between gibberish and useful thing. It's a midpoint, it's a middle point somewhere. It takes time. It takes time to work with data. It takes time to understand the data. Once you understand the data, it becomes easy for you to decide your stopwords. It becomes easy for you to do pre-processing. You're good to go with the code.
Yes, yes.
So in the presentation, we are left with only one slide. Just cover it here. If a Nick. My screen is good.
Yes, the screen is visible.
So what is there in your screen? Like, is it modern NLP and transformers? So yeah, is what?
I couldn't hear you. Can you repeat?
Yeah, your
What's
voice is breaking.
Oh, I was asking what's there visible, like what's visible on your screen? Like, is the presentation there on your screen?
Yeah,
Yes, the
it's visible. Yeah, it
presentation is
was
there.
modern NLP and transformers was visible here.
That's what. So till now we have understood the traditional methods we have in NLP. What we have been doing, like everything like word embedding and all these things are back, have a date back. They have been dated back to more than 10 years. They have been there in the market since 10 years. Uh, why they make relevance till now? Because we just can't use these heavy transformers in all the use cases. We need to have this, access, we need to have knowledge to ones which are used for basic tasks like spam detection. You can do spam detection using logistic regression. Logistic regression is pretty good at doing spam detection. If you feed in the stop words properly, then it's very much able to capture the spam or not spam. Because this kind of task is simply based on keywords. You are looking for spam or not spam, what are the key things you will see? If a email has to be flagged as a spam, then it should have some words like sale, discount, off, urgent, uh, apply, quickly apply. Like these are the words which are used for marketing. These to create urgency. So such kind of emails will be automatically classified as a spam. So categorizing text, classifying text based on the keyword is a more of an easy task. If you talk about sentiment analysis, are you able to understand the difference between both the use cases? How logistic regression is winning at one place and losing at other? The reason behind it. I hope you guys are doing. So
Yeah.
in this slide, we will be spotlighting the latest innovations and trends, which is shaping 2025 and will be shaping 2026 as well. We have drawn some of the recent industry reports and developments. So we are now going to upgrade, and this upgrade is from high-speed train to a hyperloop, very fast, like very much faster than what we were already facing. It's more integrated in the current scenarios, and it has already broadened our ethical norms. We are able to tune our ethical norms more easily, more accessibly now. So in this slide, we will cover the advanced builds we have across different domains for real world examples. So here the models which we'll be discussing are very much resource heavy. What resource heavy models here mean is they need a massive amount of computation, massive amount of servers and GPUs to run, which makes it ideal for real world analysis where we have a bunch of data coming, like we have zillions and trillions of data coming in every day. We can't rely on simple models like word to vec or other word embedding models. We need context awareness. Even if you talk about our LLMs, if you have noticed that if you had a conversation with an LLM and you are doing another conversation which is somehow related to the last one, it is able to memorize, it is able to have that context which you have already mentioned in the past. Have you noticed that thing in NLP, in LLMs like ChatGPT, Perplexity? Have you noticed it? That if you have already informed something to the model, to the ChatGPT, it's able to retain it for a longer time. Even if you go into another chat window, it's still able to somehow recall what you have told him in the other chat box. So such kind of context awareness is built using these NLP models in these NLP techniques, where we are involving transformers at backend. These transformers are enriching our GPT-4 or Cloud or Gemini. So in brief we call them multi-model NLP, where models like GPT-4, Claude, and Gemini are able to process text alongside not just text. It is also able to process images, audios, which somehow broadens our application. We are more able to perform tasks like transcript or whether it's describing a visual data. We are able to do transcribing or we are able to mark, we are able to describe visual information with context. So here it's like in this multimodal NLP, it's like you are adding a sense to a robot, a sense of vision, a sense of sound to make language understandable, like we humans do. Like we humans take in visual information, we take in sound, audio information, we process it into our brain, and we come up with a perception. Everything we observe around us makes a perception in our mind. So similarly, we are trying to inhibit, we are trying to uh, copy in a way we humans are working. Similarly, we are feeding into such kind of multimodal NLPs to mm, work along parallelly. The major keyword out here is parallel processing. We are not sticking to a process where we need to, first of all, we need to take the text in, then we have to wait for a certain time for it to convert into text vector value. And then the other step, we will convert the vector response back into the textual form. This is not a different step. We are doing it parallelly in a same set of model uh, using encoder and decoder. So this is also a very important keyword out here, that in NLP, transformers use encoders and decoders to do parallel processing. So if someone asks you, how do we do parallel processing, you can simply come up with an answer that we use encoders and decoders to process parallel. Are are we clear on that point? Are we clear on multimodal NLP? How GPT-4 and GPT-4 and others LLM models are able to process text?
Yes, yes.
As we have we have all came across the terms like LLM, large language model, and it has become a very fancy word in the past few years. But for a fact, now we are moving towards a era where we are understanding, we are realizing that even small language models are efficient enough for many use cases. It's not necessary that we stick on to LLMs for our job. We can have small language model which has lesser of a parameter. Like if you talk about GPT-4, it had 1.76 trillion parameters. But on the other hand, if you talk about Mistral, it barely has 7 billion. So you can just understand the estimate that where is 1.76 trillion and where is 8 billion. A huge difference is there in parameters. But still, small language models like Mistral and Anthropic are way good at their work. If you train them for your own use case, if you have them locally on your servers, they perform way better than LLMs. And they also solve problems like security issues, which was a major concern with LLM, that you might face a data leakage, or you might face a hallucination. Your LLM might start hallucinating over a period of time. But such kind of problems are pretty much solved with SLM, and they are very efficient. Why they are efficient? Because organizations can have their own SLMs. They can have their own SLMs locally present in their server, which could act as a personalized assistant, which could act as a personalized organizer, which has all the information about your organization, which has all the information about you, and it can behave for you. It can attend different jobs, different tasks for you. It can attend needs for you. It can talk on your behalf. So such kind of applications in agentic AI nowadays are getting possible using SLMs. Even LLMs are also a solution, but not every task can be tackled with LLMs, as we know the problems with LLM. So such kind of issues where we don't need very much very complex architectures. We need something simple. SLM is a choice, is a good choice. And it doesn't mean that SLM has a name, that it is a small language model, so it's only for simple tasks. No, that's not the case. It has proved at many places that SLMs are able to underperform, or like it is overperforming LLMs over complex tasks. All you need is fine tuning. The key point to be remembered in SLM is fine tuning is required on the domain you are seeking. On the domain data, you have to fine tune the architecture. Okay. In this same thing, I will share an example from my life, in my experience, that when I was making a project over lung cancer detection, I have used a model which is named as VIT B16. It's a pre-trained model, which is VIT here is Vision Transformer. Vision transformer is an alternative for transformer where we rather than we put in textual data, we put pixel data. We feed pixel by pixel data into the model. This model was already trained by ImageNet. They have already trained by ImageNet on basic visual classification. And on the top layers of this LLM, we feed in my domain specific data, whatever my domain was. Like my domain here is lung cancer. So I have fed in the lung cancer images. And now this LLM, this huge LLM is able to classify between different classes of cancer. There are four classes in cancer: carcinoma, adenocarcinoma, large cell, and normal state. But the problem here, why I'm discussing this is the problem here was when it came about two similar kind of classes, which barely had some difference between them. My LLM failed. My LLM wasn't able to capture that minute difference between those two similar classes. The reason behind is the huge architecture, the huge build of this VIT. But on the other hand, my very good friend has used mobile VIT. Mobile VIT is a smaller version of VIT, which you can call a SLM, and it outperformed the task. It was able to capture more of details, and it was easily we were easily able to deploy it on local devices. So you are getting multiple benefits when you are considering SLM in the task. So if you are planning to build something in future, have a consideration about small language models. Even they can outperform on multiple complex tasks. All you need is fine tuning on domain data. Whatever domain data you're using, you have to fine tune over that. You have to fine tune the model over that. Am I clear with SLM and its efficiency?
Yes.
Are you guys able to understand what SLM is? It's simply a replication of LLM, but a smaller version. SLM is like a younger brother to LLM with lesser parameters, less number of parameters. Then we talk about the autonomous agents. These agents are supposed to plan and execute the task. And these planning and execution of task is supposed to be done autonomously without any human intervention. So these are able to create a simulation of cause and effect. These models are able to create a simulation of cause and effect based on which they plan their task and they execute it for you. So if you are creating an agent in finance automation, so this will be like it analyzes the market trends and it will suggest you trades based on that. If you talk about stocks itself, if you have created an autonomous agent for stocks, sorry. So just a moment, just a moment, I'm just getting fast. Yeah. So if you are creating an autonomous agent for stock market value, so what this agent will do is in real time, it will monitor all the stocks you have assigned it to. So that is what planning is. Then it will look for patterns, analyze the pattern, see whether the stock values are growing or falling. Based on that, it will give you insights. So the part which humans were supposed to do the analysis part. Now we have machines, we have agents for that to do. We just need to look into the insights and we can make decisions over that. So not just in finance, a lot of sectors are nowadays involving autonomous agents. Uh, to tell you a fact, uh, creating autonomous agents itself has become a business point of view. there are multiple autonomous automation agencies running across the world whose task their task is only to automate work for you, whether it's making a personalized assistant or making domain specific agents. If you talk about education, in education it could be a auto grader, an agent who is able to uh, take in the answers from the student. If you are having an online quiz, so the data from the online quiz can directly go into the agent and it can do grading over it, and it can provide you the result also. The benefit with these agents are you can customize it with your own use case. You can make your own nodes. And nowadays, we even have drag and drop platforms where you don't even need to type in the code. You simply need to drag and drop, or low code, no code tools like Langflow or N8N. Such kind of platforms are offering drag and drop features to create our agents. All you need to focus on is the workflow. What is your workflow? Once you are clear with the workflow, once you're clear with the agent, you can create your agent and sell it to the market. This is also a very good business point of view. People are doing this in real time. People are doing this across the globe. They are creating their agents and they're selling it for price to the all the non-tech people, or even the tech people also buying agents who are not that proficient, who are not that competent in creating their own agents. And to consider the fact that NLP will be enriched, it will be equipped with quantum soon, as quantum computing is accelerating across the globe. All the tech giants are competing with each other to bring in this new revolution. So you can call quantum computing the next generation of computing, where we will not be talking in bits, we will be talking in qubits, where the possibility is that where in bits either the value will be 0 or 1, but in qubits it's a random state. It's a random state between 0 and 1. It could be 0, it could be 1, and it could be everything in between at the same point of time. Am I audible to you guys? Was I
Yes, you're audible. Yeah.
Yeah. So, to consider the fact that quantum computing will step into this revolution of computers, this will be the next generation of computing, where the use case and the application is just limitless. You can't think of a limit in quantum computing. What we will be doing and how we will be revolutionizing in this field, whether it's about generation or it's about search, we will be completely revolutionizing the market, thus current scenarios. But obviously, this is a fact for future. We should only have a consideration. Um, we should only have an acknowledgement about it. It's not completely there in the market yet. It's yet in the progress. So uh, the word supercomputer is somewhat fulfilled. The dream of a supercomputer is somewhat fulfilled by the quantum technology, the quantum computing. So one more interesting task I'd like to give you to inquire more about quantum computing, understand the key tech giants involved in it, and what are they actually doing right now? Like what are their current progress? Obviously, this is a very interesting point to be like if you go into depth, you will find quantum computing really interesting. Whether it's about its working or whether it's about its application, it's endless. So my suggestion is to go into quantum computing as well. Have an eye on it. Have a track on it. What's there? What's going there in the market? Apart from that, this progressively increasing trend in AI has raised a flag about biases or about privacy, especially in conversational AI, where we are communicating with the AI, where we are sharing our personal thoughts or personal facts with the AI. So these increasing usage is creating a concern about the privacy issues or bias mitigation. So we have to involve an ethical usage of AI. We should have proper laws and regulations, as European countries are already having such AI regulations uh, to monitor, to regulate the usage of AI in their region. Similarly, our government also has to focus into that. As an individual practitioner, also you should have an ethical approach towards the AI rather than going unethical or exploiting what we are having. The purpose of having an ethical AI is to making AI a bless for us rather than a still. It should benefit human mankind. And these all NLP, computer vision, and what do you call it? Robotics. They all come in together to create products in AR, augmented reality, VR, virtual reality. Uh, if you have ever noticed or if you have ever experienced AR or VR, it involves senses like vision and audio. Anyone of you have you ever experienced something like AR or VR? Any applications of virtual reality or augmented reality in your real life? So this is like a virtual assistants in the metaverse. Uh, these are the next level of NLP experiences we want to be facing, we want to be experiencing. Then we have edge computing, which enables real-time processing on device. It reduces the latency, and it's a very liable and vital tech behind the IoT applications, all the Internet of Thing applications, where we are using sensors and output devices to capture the trends around us. But, not exactly trends, but to capture the how do I call it? Like if you're creating an edge computing device for a home management system, so what and all things you will include? You will include a heat sensor, a light sensor, and you can include a proximity sensor. You can track down motion across across the home. It's already there in use. Like countries like US are already using such kind of edge computing to have more secured environment. And they are like I'm not exactly getting the name that for that thing. That home assistance where you are your whole home is houses covered. Yeah. It's like if someone tries to break in, these edge computing alerts you. They will automatically send text to your phone numbers. They will inform you with the picture of the intruder and all such things. It will also make a call to 911, their number for uh, the officials. So such kind of edge computings are involving emerging. Uh, they themselves are a business in itself. Like people are interested in such kind of edge computing tech, where they can monitor their goodies. Even shop owners are using this to monitor their shops to see like nowadays the cameras are not just capturing the movement across the it is able to annotate, it is able to box annotate what's happening in the frame. So such kind of advanced applications involve NLP in them. That's it. And if you talk about the future of AI, the coming future is mostly as a we can talk about it as a software as a service, where automation is going to save a lot of cost. Like chatbots will be heavily implied in the industry for retail, and these chatbots will be able to cut down the cost for customer services and all the extra services bared by the organization. These work can be autonomously done by these chatbots. As we know, agents are also there, so we can guide the chatbot to work according to you. All you need to do is create the workflow accordingly in an agentic AI. So whether it's about log analysis or predictive maintenance, both could be done using such kind of measures. We can engineer such kind of product for the audience. And one more time, I'll like to discuss the fact that you can't just rely on the accuracy. You have to go beyond accuracy when we are treating models, when we are creating models. So if so here in NLP also the metrics depend upon the application. If you're doing summarization, rogue is enough, ROUGE. Or if you're doing translation, then you have to go into blue. Or we are making agents, then we have to create custom metrics for an agent. We simply can't create an agent and deploy it to the market. We have to test our agent whether it's able to do its task properly or not, whether it's able to complete the task in a way we want it to do it. So such kind of evaluation are required beyond accuracy. You just can't rely on accuracy itself. That's all about NLP multimodals and the agentic frontiers we have. Apart from that, we have also considered the ethical use of AI, proper regulations for AI, so that the technologies, the challenges can be resolved and the technologies can be deployed at a larger scale. What about your thoughts on quantum NLP? What do you think could be the possible applications we might face after we get into quantum computing or quantum NLP? Any thoughts on that? I'd love to hear. Or if you guys don't have any thoughts yet, I'm seeking potential questions and potential queries from you guys at the next session. We should have something we can talk about over quantum NLP and edge computing. Anything doubtful till now? Anything you guys find difficult to digest or understand? Any part of the slide? Lakshya is one.
Nothing as of now, though I understood it.
So I believe we are up to date in NLP. Right, Lakshya?
Yeah.
Okay. What about this one?
Yes, like the doubts will arise when I will read it again.
So did you understood the task you are given with you both? Three tasks today
Yes.
you have got. First, to increase the metrics, to increase the accuracy metrics for the model. Second, to implement real-time fetching of tweets from the Twitter. Third, to look into quantum computing in NLP. How quantum is making a revolution in NLP.
Yep,
I
correct.
hope you, I hope you guys have noted that.
Yes.
Yeah.
Great.
And I think we need to communicate this back to the entire batch as well, so that they also work on this in parallel.
Yes.
Okay.
So, what's the call out here, sir? Should we wind up here?
Oh yeah, let's go ahead and write up and maybe so Lakshya, Rizwan, next week is Diwali weekend. We have to figure out. Maybe we'll put the poll on Monday itself. If there is a possibility to have a conversation during the week, great. Otherwise, we have to figure out what is the best next available slot with us.
Sure, sir.
Okay.
Yes.
All right. Okay. Okay. All right. Thank you so much, Dev.
Yes,
Thanks,
sir.
everyone.
Thank
Thank
you.
you, guys.